This is Precalculus video lecture number 8 on library of functions and piecewise-defined functions. Now, to start off this lesson, we're going to go over 7 basic graphs or parent functions, and it's going to be crucial that you put all of these properties and shapes to memory as well as the key points, because coming up in the next lesson, we're going to learn how to apply transformations. So you won't be able to transform a graph unless you know what the parent graph looks like, and you have to have it burned in the brain. Okay, so here we go. We're not going to make a table. I'm just going to tell you what the key points are for each of the graphs. And if you want to sit there and make a table in your own time and verify it, go for it. So here we go. Y equals x squared. Hopefully you remember this guy. Yes, it's a parabola. And it has a nice little U shape. Okay, key points. The key points are going to be the points that we use to identify the parent function, and then we're going to apply transformations in the next lesson to these key points to figure out what the new graph looks like. On a parabola, I want you to use negative 1, 1, 0, 0, 1, 1. Obviously, you could use other points too, but what's nice about this is it includes the vertex at 0, 0. And then it includes another point on the left side of the parabola, another point on the right side, and they're easy enough to work with. Okay, this is the bare minimum, if you're one of my students, that I would look for when you're working with the graph. 3 key points. Okay, if you want to knock yourself out and get a little fancier, then you're going to add in negative 2, 4 and 2, 4. And I'm just getting these values by substituting in for x, right? Negative 1, 0, 1, 2, blah, blah, blah. So negative 2, 4, 2, 4, and there's our parabola. Make sure you show that it's a parabola. Make sure you show it's a U shape, not straight lines, because we are going to work with a graph that has straight lines on both sides in just a hot second. So you want to differentiate between the two. And put your arrows. If you don't put arrows, then it means the graph ends, which is wrong. All right, let's also list out the domain and range. So the domain is going to be all real numbers. And then based on the graph, can you see what the range is? Smallest y value is 0 and up until positive infinity. Good. Next is y equals x cubed, the cube function. Okay, key points, just plugging in for x, negative 1, 0, and 1, you get back negative 1, 0, and 1. So these are the key points that we're going to use. And then if you want a few more just to help you out to understand what the shape is, you could plug in negative 2, you get negative 8, and positive 2, positive 8. So what's it looking like? 2, 8 is like this, negative 1, negative 1, negative 2, negative 8. Okay, so here's your x cubed function. Very nice. Now, what's the domain? The domain is all real numbers. So negative infinity to infinity. And don't just go by what you see. Sometimes you're like, oh, I don't see a whole lot of x values. But think about what you are allowed to substitute in for x, right? Any real number is fine. And then the range, again, is also going to be all real numbers. So negative infinity to infinity. Good, good, good. Okay. Let's move on to some more spicy stuff. So y equals the square root of x. That's the square root function. Now let's think about it. I'm not allowed to plug in a negative number for x, right? Can't take the square root of a negative. All these graphs, we're graphing in the real 2-dimensional coordinate system. Okay. Smallest number I could plug in is 0, right? Square root of 0 is 0. Next number I could plug in is 1. Square root of 1 is 1. And remember, these key points, you're going to be using them a lot. So be kind to yourself. Do you want to use 2 for your next x value? Do you want to work with the square root of 2? I certainly don't. I'd rather plug in 4 for x, and then the y coordinate's going to be 2, right? Be nice to yourself. So these are the key points that we're going to work with. And let's plot them. So 0, 0, that's not going to have an arrow on it. Remember, we said we couldn't plug in anything negative. So we've got 0, 0, 1, 1. 4, 2. And there's our graph. So it's just the upper half of a parabola opening up on the positive x-axis. More about that later. What's the domain? Well, it looks like smallest we could go is 0 up until positive infinity. And now how about the range? Same for the range. Smallest is 0 up until positive infinity. Good. Okay, next is y equals cube root of x, cube root function. Again, are we allowed to plug in negatives? Yes. Think back to when we were finding domains of functions. For radical functions with an odd index, the domain is all real numbers. We have no restrictions. So you can totally take the cube root of a negative number, no problem. So cube root of -1 is -1, cube root of 0 is 0, cube root of 1 is 1. So this is enough for your key points. However, if you only use these, you run into some danger because notice they're the exact same key points as on x cubed. Does that mean these graphs have the same shape? No, it does not. So let's plug in a few more points just in case you don't know what the shape is yet. If I plug in an 8 for x, the cube root of 8 is 2. And if I were to plug in -8, the cube root is -2. So now let's see what's going on. So we've got -1, -1, 0, 0, 1, 1. And then we have 8, 2, and -8, -2. You see how this graph, the cube root graph, well, it looks like someone came and knocked over x cubed, right? After they reflected it. So it's more flat. It's not increasing as quickly. Now, these key points down here are optional, okay? If you're one of my students, as long as you have these 3 down when you're doing transformations, that's fine. You're just going to have your wits about you and remember the shape of cube root of x and don't make it look like x cubed if you don't want to do the extra 2 points, okay? If you can't trust yourself, then just do all 5 points. That way you're forced to draw the graph correctly. How about domain and range? So domain looks like it's all real numbers again, -infinity to infinity. And the range, same thing, right? It's going to go all the way to -infinity, just not as quickly as x cubed. So those arrows indicate it keeps going. So -infinity to infinity. Don't go off of just what you see. All right. Next, absolute value function, y equals absolute value of x. So let's substitute in some values. -1, absolute value of -1 is 1. 0, 0, 1, 1. Oh my goodness, this is the same as the key points on the parabola. This is getting dangerous, guys. Okay, so plug in a few more. -2 would give us +2, 2, 2. So this is why I made a big deal that you need to put curved lines on the parabola to show it has a U shape, because absolute value is a V shape with straight lines. Yes. Good, good. Again, what's the domain? All real numbers, -infinity to infinity, and the range looks like it goes from 0 to positive infinity. Okay, good. Now, y equals 1 over x, the reciprocal function. When we do our unit on rational functions, we'll study this in more detail, but for now, just keep in mind the following. So we've got asymptotes on this graph. You should be familiar with asymptotes from when you studied trig. Okay, tangent has an asymptote, cotangent, secant, cosecant, all those good graphs. So let's think about where we would have asymptotes. First obvious place is where x is 0, because that value is not in the domain for the function. So we have a vertical asymptote there at x equals 0. We also have a horizontal asymptote at y equals 0. Okay, you have to write the equations of the asymptotes every time you do one of these graphs. And then you actually only have 2 key points to contend with. Okay, so plug in something nice. If you plug in 1 for x, 1 over 1 is 1. And then if you plug in -1 for x, the y value is -1. So you've got this point and this point. And I'm not going to torture you with having to remember a bunch of other points. It's just not necessary. If you want to play around with it so you can see what the shape is, go for it. But basically, you've got one portion of the graph that lives in quadrant 1 like this, and it gets close to the asymptotes. And then the other portion that lives in quadrant 3. Okay, that's what your graph looks like. Got it? The domain is, you could write it one of two ways, x such that x doesn't equal 0. Or do you remember how I showed you before to write it in interval notation? You go negative infinity up until 0, but don't include it. But don't put glasses on it either. Oh my goodness. Okay. Union 0 to infinity, right? You just skip over 0. And then what about the range? What's the range on this guy? It's actually the same, y such that y doesn't equal 0. Beautiful. Okay, so in this case, you only have 2 key points, all right? But instead of like using a third key point, you have to give the equation of the asymptotes. That's the complete package. Last one. We made it. Y equals 1 over x squared. So again, this graph has asymptotes at x equals 0 and y equals 0. Anytime the asymptotes are on the axes, it's hard to tell, right, when you're graphing. So that's why I just add a little bit extra dashed above and below and to the left and to the right to remind me that they're asymptotes. We're not going to touch them, the vertical ones for sure. Okay, and then the key points, if I plug in 1 for x, I get 1 for y. And then this time, if I plug in negative 1 for x, since it's squared, I get positive 1 for y. So what does that mean? That means both halves of the graph lie above the x-axis. It's like this. Okay, good. Now what's the domain? The domain is same as for reciprocal function, x such that x doesn't equal 0. Or you could write negative infinity to 0, union 0 to infinity. Now what about the range? Be careful. Notice the entire graph lies above the x-axis. So it would be all y's such that y is strictly greater than 0, not even equal to. Or how would you write that in interval notation? Do you know? You would go 0 to infinity. Okay, so you need all of this whenever you graph it. Good, so whatever you need to do to make sure you remember the shape of the graphs and the key points, and then hopefully you can just look at it and figure out the domain and range. I wouldn't necessarily add that. Do you kids make note cards anymore, flashcards, whatever you do, just make sure you learn it, okay? Good. Now, moving on to the next topic in this lesson, piecewise-defined functions. So a piecewise-defined function is when you have 2 or more functions that have basically been pasted together, and for different parts of the domain for the function, it's defined to be different kinds of functions. So if you'll notice here, instead of saying f of x equals and you only have one equation, you have multiple equations for different parts or different x values that the graph takes on. So notice here we have f of x equals negative 3x if x is less than negative 1. F of x equals 0 if x equals negative 1. And then f of x equals 2x squared plus 1 if x is greater than negative 1. Okay, now when you get more comfortable with these, you'll probably be able to just look at the piecewise function and start graphing, okay? But a lot of the time when students first see them, it's a little overwhelming. So I'll show you a way to make a table if it makes you feel more comfortable, but it's totally optional. Only do it if you love it and you feel like it's needed, okay? We'll get to that in a minute. So let's start off. It says sketch the graph first, but we're not. We're gonna do part B. Find f of negative 2. So first you have to determine where you're gonna plug in the negative 2. So notice negative 2, it's less than negative 1, isn't it? So I'm going to use the equation f of x equals negative 3x when I'm evaluating f of negative 2. So I have negative 3 times negative 2, which is positive 6. That's my answer there. Okay, find f of 0. So if I'm going to substitute in 0 for x, I first have to determine which part of the function applies. F of 0, 0 is greater than negative 1. So I'm going to substitute it in here to 2x squared plus 1. So this is going to be 2 times 0 squared plus 1, which is 1. Okay. And then lastly, find f of negative 1. So if x actually equals negative 1, the function tells me the y value is 0. I don't plug in -1 anywhere. It just says, hey, it's 0. That's it. It's a constant. Okay, got it. So that's that. Now we're going to sketch the graph. So you can put these points on the graph if you want. I'm going to show you how to make a table though. And when you set your table up, what you're going to have to do is identify where the domain splits. Okay, so the domain splits at -1. So I'm going to repeat that value 3 times on my table. And I'll put a little bit to the left and then a little bit to the right. And then hopefully from there, you'll have a good idea of what's going on. So here's x, here's f of x. So a little bit to the left of -1, we can go to -2 and -3. How's that sound? That should be enough. Okay, so -3, -2, and -1. These I'm going to substitute into the equation -3x. And notice here, this is important. This is super important. Since x is strictly less than -1, when f of x equals -3x, this is going to be graphed with an open circle, not a closed circle. Okay? Good. Again, I'm going to repeat -1, and this time f of x is actually equal to 0. That gets filled in. That's the actual function value, so that'll be a solid point on the graph. And then I'm going to repeat -1 again, so we have -1, 0, 1, 2. All of these values are greater than -1, so these are going to get substituted into 2x squared plus 1. And then again here, since x is strictly greater than -1, it's going to be with an open circle. Okay, good. I have to repeat -1 on the graph because since x is strictly greater than -1, it can get as close to -1 from the right side, but not equal it. So you don't want to cut it off at like -0.5, -0.6, because you can always get a wee bit closer, a wee bit closer. So you just include the endpoint on your graph, but you use an open circle. All right. Okay, here we go. So now we just plug it into the equations. So see how I've reminded myself where to plug it into? So convenient. So -3 into -3x, that's +9. Then we have +6, and then I have +3. And then now for the other values, I'm substituting into 2x squared plus 1. So square -1 times 2, that's 2 plus 1 is 3. 0 plus 1 is 1. 2 plus 1 is 3. That's going to be 4 times 2, so 8 plus 1 is 9. Okay, looks like we are ready to roll. So if you want to make a table, you can. If you feel comfortable without, don't. All right, -3, 9, that's right here. -2, 6 is here. And -1, 3, remember this one's with the open circle. Now this is only for where x is less than -1. So this is a line, right? Linear function, but I'm only going to draw it to the left. I'm not going to pass -1. Over here, it's equal to -3x, and that's it. Open circle. Don't forget that open circle. Now, at -1, we have a y value of 0, right? Do you remember they told us this one? So here we go. There's -1, 0. Love it. And then now the rest of the graph, I'm going to switch colors just so you could see it clearly. I have -1, 3, open circle. Oh, I already have an open circle there. It's still an open circle, okay? Open circle plus another open circle on top of it does not make a closed circle. No, no, no. Then we have 0, 1, 1, 3, and 2, 9. So this here is our parabola. So this is a parabola. And then this is a line. And the parabola is defined on the other side of -1. So this is 2x squared plus 1. And there's our graph. It's got a hole in it. Oh no, it's okay, don't worry. You didn't do anything wrong. Good? All right. Moving on. Should we write the domain and range? Why not? use the graph. The domain, let's see here. So x could take on any real value, negative infinity to infinity. Now for the range, be careful. So it looks like on the parabola, the smallest value is 1, and then it goes up to positive infinity. But then don't forget, we've got this random little value of 0 hanging out there. So what do you do with that? You say take 0 by his lonesome, and then union it up with the interval from 1 to infinity. Okay, I just wanted to show you that. That's why I couldn't resist. Good. Let's do another one. These take some practice, I dare say. Let f of x equal 2x plus 5 if x is greater than or equal to negative 3 but less than 0. Negative 3 if x is 0. And then negative 5x if x is greater than 0. Okay? Now they're asking us to find domain, intercepts, range. Let's do the graph first. And we can set up a table again if you like. Okay? Notice here the domain splits again at 0. However, it's not going to go all the way down to negative infinity. In this case, we're bounded below by negative 3. So that should be the smallest x value that I put on my table. They're restricting us this time. So we've got x, f of x, and I'll put negative 3, negative 2, negative 1, and 0, and these all get substituted into 2x plus 5. I'm going to remind myself this 0 is with an open circle. How do I know that? Because this x is strictly less than 0 for 2x plus 5. And then I have 0 with the closed circle, and the y value is negative 3, the function value. And then if x is greater than 0, so again, open circle, 1, 2, that should be enough. It's just negative 5x. That's a linear function. You really only need 2 points. Okay, so here we go. I'm going to substitute it into the function now. So negative 3, plugging that in for x into 2x plus 5, that's going to be negative 6 plus 5, so negative 1. If I plug in negative 2, that's negative 4 plus 5, so that's positive 1. Then we're going to get 3 and then 5. And then now I'm going to work with negative 5x. These are going to give me 0, negative 5, negative 10. All right, very good. So here we go. At negative 3, I have negative 1. At negative 2, positive 1. And negative 1, 3. Oops. No, that's okay. 0, 5 is my open circle. Oh my goodness, I almost had a panic attack. Okay, so I'm going to connect these. No arrows on this guy though, because remember, x is strictly greater than negative 3, but it doesn't keep going to negative infinity. So that's all you draw for that portion. All right, next part. At 0, I'm going to plot negative 3. There's that one little lonesome point. Okay, moving on. 0, 0, open circle. 1, negative 5. And 2, negative 10. So this part will have an arrow, right? Because this is unbounded. X is greater than 0 and it goes on forever and ever. Okay, good. There's our graph. How do you feel about it? It's all right. Okay. I mean, it's correct. So find the domain of the function. All right. So it looks like the smallest x value, remember, we were allowed to plug in was negative 3, but we were unbounded in the positive direction. So positive infinity is fine. Find the x and y intercepts. So the graph can help us. Okay. For the x-intercepts, you substitute or you set y equal to 0, right? Now, based off of the graph, it looks like we have an intercept here, and that was on the portion where f of x was equal to 2x plus 5. So I'm just going to set 2x plus 5 equal to 0, which means x equals negative 5 halves. So the x-intercept is at negative 5 halves, 0. Now, what about the y-intercept? Do we have one? Yeah, actually, it's this point here that they defined, negative 3. So the y-intercept is at 0, negative 3. That's it. And then based on the graph, find the range. Okay, So for the range, you're looking at the y values. What's the smallest y value that you see the graph take on? Well, you don't, because it goes down to negative infinity. Okay, now what about the largest y value? So look, the graph's going to assume all values. I know there's a hole here, but don't worry because it does equal 0. Y equals 0 right there. So it's not like that value is missing from the range. And it goes all the way up to, but it does not include 5. Do you see that? So how would I write that out? In interval notation, negative infinity to 5 with parentheses. I didn't write it in set builder. Do you like set builder? Most students don't. Y such that y is, in this case, strictly less than 5. And the domain would be x such that x is greater than or equal to negative 3. Just pay attention to the directions. If the directions specify which notation, then you obviously have to do it using what they say. But otherwise, it's up to you. Okay? So that concludes the lesson. Be sure to give it a thumbs up and subscribe. And then stay tuned because the next video we're going to work on transformation. So make sure you memorize all the key points on those parent functions. That way you can keep up with all the fun.